Assalamu alaikum and good afternoon to one and all. So in today's practical, we will study about pharmacology experiment of matching bioassay. I am Professor Sheikh Abu Sufyan. Welcome you to AS Academy Learning Forever. At the end of this e-learning session, you are able to answer what is matching bioassay and its principle, when and how to perform it, what are its advantages as compared to other types of bioassay. So we'll study how to perform the bioassay. First we'll see what is the meaning of matching bioassay. So remember that matching bioassay, it is the assay where you match the response of the standard with that response of the test. So what you are doing basically, you are matching response of the standard with the response of the test. Okay. So when you are doing that, this type of bioassay, it is called as matching bioassay. So basically here the measurement of unknown concentration, it is not depend upon the measurement of the test response, but it is depends on the matching of the standard response with that of test. Okay. So this is about the matching bioassay. Now let's see when to perform matching bioassay, in which condition as a experimental pharmacologist you will recommend matching types of bioassay. So remember that when you are doing investigation and you have synthesized the drug in very small quantity. So in such cases, if you have small amount of the sample and if you want to study their pharmacological effect and you want to know, then in such case you can surely go for the matching bioassay. So this we have seen, when small amount of sample is available, then you can go for the matching bioassay. Okay. Now let's see how to perform matching bioassay. So the way we perform all other types of bioassay, like we did in last practical about interpolation bioassay, you did that experiment. In the similar fashion, we also take the reading in case of the matching bioassay. So every time whenever we conduct any type of bioassay, first we take the reading of the standard. Why we take those reading of the standard? Because it is required to check your tissue reproducibility, whether your tissue it is reproducible or not, or whether it is sensitive or not, so that you will come to know with the different reading of your the sample. Okay. So to check the tissue reproducibility and the tissue sensitivity, you perform the DRC, that is dose response curve of the standard. So let's see how to perform it. So the first response that you take while performing the DRC of the standard, it is you study the equipotency of your standard dose. Okay. So what you are doing there you are taking the two response of the standard. Like suppose you are given the first dose that may be of the 0.1 ml. So you are given the first dose of the 0.1 ml. Then you are again repeating the same dose of the standard, isn't it? So now you are given the another dose of the standard, and this dose it is again 0.1 ml. So when dose it is same and you have getting the same response, so both response height, suppose if it is coming to 10 mm and here also if it is coming to the 10 mm, so that indicate that it now you whatever response you got, these response are equipotent in nature. Okay. So these response are called as equipotent. Why they are equipotent? Because you have given the same dose and you have got the same response. So at same dose, when you get same response, or these doses are called as equipotent in nature. Okay. Now as a process, we need to give the different dose of the standard. So we'll be giving the next dose. So when we have given the next dose, suppose if it is of the 0.2 ml, now what happened as compared to our earlier response? So you can see here the height of the response it is increased because you have increased the dose. Okay. So now you can keep on giving the dose of the drug. So now you are given the next dose, you are given the 0.4 ml. So it is the double of the earlier dose. Again you can see there is increase in the height. So as you increase the dose, there is increase in a height of the response. So that is seen in case of this type of bioassay. So this type of bioassay, they are called as graded bioassay, because what is happening here, you increase the dose, you are getting increase in a response. So you call this type of bioassay as a graded bioassay. So you can continue this process, means you are keep on increasing the dose to get your response. So you are given next dose 1.6, there also you got increase in a response as compared to 0.8 ml dose. Now you have given the next dose. Suppose you have given the next dose, that is of the 3.2, and you have observed their response. So when you observe the response of the 3.2, you have seen that the response of the 1.6 and the response of 3.2, they are similar. Means there is no increase in the response and is observed at the dose of 3.2 as compared to the response of 1.6, isn't it? Why it's happened? Because in earlier case, from 0.1 to 1.6, as we increase the dose, we got increase in the response. So we got the gradation, we got nice gradation. This type of bioassay is called as graded bioassay. But this is what is happening here at 3.2. When you have, although you have increased the dose, that is double of 1.6, but response it is not increased. So this point it indicates that now there is ceiling effect, it is reached. Okay, so it is called as ceiling effect. So what is happening at ceiling effect? You have increased the dose, but there is no increase in a response. So this indicate the ceiling effect. And why this you see the ceiling effect? Because there are limited number of receptor are present. Since limited number of receptor are present, all receptors are occupied by the drug. So those are occupied at the concentration of 1.6 only. So although you have increased the concentration, since extra receptor are not available, all receptors are saturated. All receptor are, I am writing here, all receptor are saturated at the dose of 3.2, and due to that, although you have increased the dose, but there is no increase in the response. So you have to continue this DRC of the standard. So the DRC means it is the dose response curve of the standard up to the ceiling effect. So once you get the ceiling effect, then you can stop giving the dose of the standard. Now again, if you want to confirm whether your tissue it is giving reproducible response or not, then what you can do, you can give one more dose of the standard. You can try with submax dose. So submax dose, it is the dose which is exactly less having the height which is exactly less than the maximum response. So what was your maximum response? So 1.6 was your maximum response. So exactly before the maximum response, it is the 0.8. Okay, so the 0.8, it is called as the submax dose. It is just before your maximum response, so you call it as the submax dose. Now you can give that submax dose over here. Now you have given that submax dose and you got certain response. Okay, so at 0.8 you got some response. So this is the submax dose, and when you measure their height, it is exactly same as this 0.8 dose. So it indicates that still your tissue it is as sensitive and as reproducible as earlier, isn't it? So now you have confirmed that your tissue it is sensitive, your tissue it is giving the reproducible responses. Now you can go ahead with the test dose. So again, which dose here we have given? 0.8 ml. This dose we have selected, it was of the submax dose. Okay, so we have selected, now we have given the submax dose, and we have ensured the reproducibility and the reproducibility of the bioassay and sensitivity of the tissue. Right, now we'll be giving the test dose. Now first thing, we need to select appropriate test dose which fall in between the DRC. Okay, so means the whatever response of the test dose that you get, it should be bigger than 0.1 ml, or it should be bigger than the response of the 0.1 ml, and it should have the response which is smaller than the response of the 1.6, that is the maximum response. Dose of the test now you can select as a final test dose. Okay, now let us say you have given the dose of the test, maybe 0.1 ml of the test you have given, you got certain response, you have measured the height of this response. When you measure the height, you observe that the height it is just 8 mm. Okay, so height you got it is 8 mm. So 8 mm means it is smaller than here, smaller than this the smallest dose of the standard, because the standard height we got it was the 10 mm. So it should be ideally bigger than 10 mm, right? So 0.1 test you have given, but response that you got, it is smaller than this 0.1 ml of the standard. So what you can do, this indicate that you need to give the next dose. So accordingly you have given the next dose of the test, and you got the response. Okay, so you got the response. So again, this may be dose that you are given, it was of the 0.2 ml of the test. So when you are given the 0.2 ml of the test, you got the response. Maybe their height, it is just 9 mm. Okay, so again it indicates that it is not the dose of the test, it is not selected, because the response of the test dose, that is 0.22, it is not falling in the DRC. So what you did, you have given the next dose of the test. So maybe you are given the next dose of test, you got the reading, maybe that is the zero point 0.4 you are given, and you got the reading, and that reading, it was almost close to the 14 mm. So since it is 14 mm, it means it is bigger than 10 mm. So it is the bigger than smallest response of the standard. It means you have selected appropriate dose of the test. So your selection of the test, it is done. So this dose of the test you have selected, that is the 0.4 ml of the test. Okay, so this is the selected, I'm writing here, it is selected test dose. It is selected test dose, so that you have selected. Now again, if you want to confirm that you have whatever response of 0.4 ml, it is exactly 14 mm, it is coming or not, then what you can do in order to confirm that, if it is needed, then you can again give one more dose of 0.4 ml of the test. So you are given 0.4 ml of this dose, and you observe that when you measure the height, it is exactly same as the response of this 0.4 ml. You got the height of the 14 mm. So it indicates that whatever test dose you have selected, it is the right one. There is no any mistake, or there is no any error. Till this, you have given the test dose. So what you are given is the test dose you are given, right? Now since we are performing the matching bioassay, what we need to do? So let's come back to their definition. It is the bioassay where you match the response of the standard with the response of the test dose, isn't it? Now what test response you got? You got the test response of the 14 mm. So your test response is 14 mm, and you want to match this response with the response of the standard. So you just look at here, when you have taken the reading of the 0.1 ml of the standard, how much response you got? You got a response of just 10 mm. So let us try with again 0.1 mm of the standard, and you have taken the response of the standard of the 0.1 ml of the standard. You got the response, that is 10 mm, isn't it? Since it is not matching with the 14 mm, you can increase the dose. So you have maybe the increase the dose again of the standard. Okay, you got the response, maybe you got the response of the 11 mm. Okay, so you have given the 0.2 ml of the standard, you got the 11 ml, 11 mm as the height. Again you have increased the dose, because 11 it is not matching with the 14 mm, so you got taken the reading. So you have given the dose of the 0.4 ml. Okay, and you got a response that is around coming to 12 mm, right? So still it is not matching, so you will give one more dose of the standard. Okay, when you given the next dose, that was of the point maybe 8 ml, and you observe that the reading of zero point 0.8 ml, it is exactly 14 mm. It is matching with the reading of the test dose that you have selected. So you got both the reading, it is 14 mm. So now your job is done. You have selected dose of the standard which is matching with the dose of your test that you have selected, isn't it? So the dose of the standard which match with the dose of the test, it is 0.8 ml. So again, if you want to confirm it, you give one more response. When you take one more response, or you give one more dose, when you give one more dose of the 0.8 ml, you got the reading that's coming again to the 14 mm. Okay, so now this is confirmed that the dose selection of the standard, it is right. So we are done with this. So your DRC of matching bioassay is done. Now let's see how to calculate unknown concentration of the drug by using matching bioassay. I hope up to this it is clear to you. Now I am going to the Excel sheet. So let's go to the Excel sheet, so where we'll come to know how to perform or how to calculate unknown concentration of the drug by using matching bioassay. So what you can do, I have already sent you a assignment. You can open that assignment. In that assignment I have shared Excel sheet. Now what data I have shared in Excel sheet? I have shared different dose of the standard and what response you received. So, and your aim of the practical is to estimate unknown concentration of acetylcholine solution by matching bioassay. So we have done with the DRC, you got the dose response curve, you have measured the response of the each dose and you have written that in front of your dose. Okay, so 0.1 ml, the corresponding response you got is 12. 0.2 ml corresponding response you got is 17, 0.4 ml corresponding response you got is 19. Likewise, till 3.2 you have taken the reading, isn't it? You have taken the reading up to 3.2. So I am just correcting this because 3.2 we got ceiling effect, so ideally it should be the same. Okay, so we got these reading up to 3.2. Now we have given different dose of the test. So we have given different dose of test. A 0.1 test we have given, we got the response 8 mm, isn't it? 0.2 dose of test we have given, we got the response that is 14 mm, and the 14 mm, this response it was bigger than 0.1. So we have selected the response of the test that is 14 mm, that is falling in between the DRC. So I have highlighted that in the red so that you can identify. Then what we did, we have given the different dose of the standard so that we can select the dose of the standard which can exactly match with the dose of your test. Okay, so we have given different dose, like one we have given, we got a response of 8 mm, so I'm just changing that, or you can use those value that I have given in Google Classroom, no issue, because you just need to calculate it. Okay, these are the dummy reading. So maybe 0.1 we got the 8 mm. Okay, 0.2 also we have studied of the standard, we are given the dose of the 0.8 mm of the standard, and accordingly we got the response of the 13 mm. Then we have given the next dose of the standard, that was the 0.4 ml. Okay, and we got the response that is 14 mm, right? Again we have repeated the same dose, that was 0.4, and we have confirmed whether we got same height or not, and we got the same height, that is 14 mm. So the 0.4 ml of the standard, it is actually matching with the 0.2 ml dose of the test. Now let's see how to calculate unknown concentration by using matching bioassay. So the formula is concentration of unknown is equal to y divided by x multiplied by c standard. So C standard, it is basically the concentration of the standard. So here in our case, the concentration of standard, it is 10 microgram per ml. Now what is Y? Y here it is, the Y is the dose of the standard that match with the test response. So dose of the standard that match with the test response, it is Y, and X is the dose of the test that is selected. So just I am writing those reading here. So Y, it is the dose of the standard that match with the test response. So which dose of the standard it match with the test response? It is the 0.4. So I am writing that here. It is the 0.4. Okay. Then X, it is dose of the test that is selected. What dose of the test you have selected here? You have selected the dose of the test, that is 0.2 ml. So I am writing 0.2 ml over here, right? And C standard, that is concentration of the standard, that is 10 microgram per ml. Now what we need to calculate? We need to calculate concentration of the unknown. So I have written question mark in front of that. So let's calculate that. So concentration of unknown is equal to the dose of the standard that match with the test. So that is Y, okay, divided by dose of the test that selected, that is X. So I have, okay, then I am writing this value in a bracket, because bracket it is multiplied by concentration of the standard. So it is multiplied by concentration of standard, that is 10 microgram per ml. So you got the concentration of the unknown. So your concentration of unknown, it is coming to 20 microgram per ml. So why it is in microgram? Because our dose of our concentration of standard, it was in microgram per ml. So you will get the concentration of the test, it is also microgram per ml. Okay, so I hope it is clear. So I have already uploaded Excel sheet on a Google Classroom. What you need to do, you need to use the data that I have given to you. You don't use this data, and calculate the unknown concentration of the drug. Copy this observation table in a journal. Okay, then you copy this calculation part, this all part, and write the result about unknown concentration of the drug, and submit only that journal. Don't submit both Excel sheet as well as journal. So there is no graph in today's experiment. Just you need to calculate unknown concentration and you have to submit that in your e-journal. Okay. So this is all about today's experiment. So I have done with my experiment. If you have any doubt, then let me know. So I'm coming live here.